Alright, Algebra 2, welcome back. In today's lesson, we want to go over simplifying radicals. So what's a radical? A radical is just a root, like a square root or a cube root or anything higher, fourth roots and fifth roots and so on. And to do this, the first thing I want my students to do is to memorize their squares and cubes. It's just going to make things a lot easier as we go through. So let's just list off our squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, then we have 16, 25, 36, 49, 8 squared is 64, then we have 81, 100, 121, 144. You can go further, but for most of our problems, that's going to be enough. And then our cubes, we're also going to use those today. And that starts out with 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. So again, that's about as enough as, that we're going to need for today. And we're going to be using this property with radicals. So this property states that the nth root of a times the nth root of b is equal to the nth root of a times b. But we're actually going to use this backwards. So we're going to use it backwards and take something like the nth root of ab and break it up into the nth root of a and the nth root of b. So for example, let's say we are talking about the square root of 72, and I want to simplify this. I want to make the number under the radical as small as possible. So I want to split this up into 2 radicals, and underneath the first one, I want this to be a perfect square. So I want that to be a perfect square. And underneath the second one, that's going to contain all my remaining or leftover factors. So all the leftover factors there. So when I take 72, what is the biggest square that divides into 72? Well, obviously 81 is too big. 72 can't divide it by 64, can't divide it evenly by 49. Oh, what about 36? That works. So we do get 36, and then the other factor, 72, is 36 times 2. And the reason we do that is because now I can take the square root of the first part. The square root of 36 is just 6. And we can tell that, we can check our answer by plugging in the square root of 72 into the calculator, plug in 6 square roots of 2 in the calculator, and we get approximately 8.485, so on. Now you might be, well, 72 is not the, there's other numbers that go into 72 besides 36. I mean, I could have used 9, right? I could have done 9 and 8, and then I would have had 3 square roots of 8. But the problem is that 8 has a square in it. That's really 4 times 2. And I want to make the number under the radical as small as possible. So this one, even though it's equivalent, is not completely simplified until I make the number under the radical as small as possible. No square factors should divide into that number. Alright, for our next example, we're going to put some variables into it as well. So this time I want to simplify the square root of 45x y cubed z squared. So again, to do this, we are going to break up our square root into 2 square roots. That's the first thing I write. And again, I want this one to contain just square factors. And when I get to the variables, I want the variables to have even exponents. So things that are divisible by 2, multiples of 2, even exponents. Like 2, 4, 6, 8, and so on. And this guy is going to contain all the leftover factors. So here's going to be all the leftovers. So I'm going to go with 45, and what's the biggest square that goes into 45? Well, 9 would be the biggest square that goes into 45, and then what's remaining? I would have a 5 over here. Now I go to the variables. What about the x? Well, x doesn't have an even exponent. It's just got one of them. To put it out here, I have to be able to pair it up with something, so the x is left over. It has to stay under the radical. I go to the y's. I have y cubed. Y cubed is not even, but how many can I pull out here? I can pull out 2. So if I just knock it down by 1, I can take y squared and put it out here, and I would have a leftover of y in the second spot. And then z squared, well, that has an even exponent, so all the z's can go out in front. So I want to put as many variables out in front and as many squares out in front as I can, and this is going to contain all the leftovers. And you should know that the exponents here, they should just be 1. So I can't have anything higher than just 1 in those spots for the exponents. Now I can take the square root of the first part. The square root of 9 is 3, and I divide the exponents by 2. So make sure you're dividing the exponents by 2. So when I divide by 2, y squared is going to give me a y, and z squared, divide the exponent by 2, I got a z, and this part is going to remain the same. So I'm just going to have square root of 5xy. So our answer would be 3yz square root of 5xy. Alright, for our next example, we're going to have the square root of 192, x to the 4th, y to the 7th, z to the 9th. And again, to do this, we're going to set up 2 square roots and do it one step at a time. First off, looking at the coefficient, looking at 192. What's the biggest square that would go into 192? Well, obviously, let's see, it's not 121, it's not 100. It has to divide evenly, no fractions or decimals. And I think it's going to be 64. So we get 64 out here. 192 divided by 64 means that 3 is going to be left over. 64 times 3 is 192. Then we go to our variables, and again we want to have even exponents out in front. So x to the 4th, that's even. There's no remaining ones to put over here. Y to the 7th. Y to the 7th is not even, but how many can we pull out that would be? The most we can pull out is 6, and we'd have a leftover of 1 y in here. And then z to the 9th, again 9 is not even, but I can put 8 out in front, and that would leave 1 left over. Now that I split it up, I can say, okay, what is the square root of this first part? The square root of 64 is 8. And then I'm going to divide the exponents by 2. So 4 divided by 2 is y squared. Y to the 6, if I divide the exponent by 2, I get 3. And z to the 8th, I would get 4. And then this part, if I've done it correctly, should never change. I should have the square root of 3yz. Okay, for this next problem, it looks very similar to the one we just did, except I made a little change. What's changed about this? Now it is a cube root. So we're going to use the same property, except now I want to split it into 2 cube roots. And it's going to be very similar to what we did, except now I want these to be perfect cubes. And when I get to the variables, I want the variables to have exponents that are multiples of 3. So exponents that are multiples of 3. What do I mean? 3, 6, 9. If I'm counting by 3s, that's what I should see for the exponents. And again, this guy is going to contain all the leftover or remaining factors. So let me just hit leftover are going to go there. And so 192, what cube goes into 192? Well, we saw that 64 does, so it's still going to be 64. 64 is one of those sneaky numbers that's both a square and a cube. So a 64 can be pulled out in front, and then we would have a 3 left over. And then we get to our variables. X to the 4th, well, is that a multiple of 3? It's not, but what's the highest we can take out here? 3 is. We just knock it down by 1. We would have x cubed there. We got a remaining x left over. Y to the 7th, is that a multiple of 3? It's not, but we can have 6 out here and 1 left over. And then z to the 9th, is that a perfect cube? That is. So 9 is a multiple of 3. And now we can simplify. Let me just erase this part. And now we can take the cube root. What is the cube root of 64? Make sure we're using the cube root and not the square root. So the cube root of 64 is 4. And we are going to divide the exponents by 3 this time. So 3 divided by 3 is 1. I don't have to write the 1 there. And then 6 divided by 3 is 2. And then z, we have to the 9th. 9 divided by 3 is 3. And we are left over with a cube root. Make sure you put a little 3 there to say it's a cube root of 3xy. And that's how we simplify radicals with square roots and cube roots. Thanks for watching. Bye.